Hey guys, we are officially on Unit 7, Lesson 4, which is magnetism. First I would like to draw a fancy little magnet. So we have an N and an S for the North and South Pole. So this we would call a bar magnet. Whoop. I would like to remind you that the ends are called poles. So we have the North Pole and the South Pole. Again, magnetism is what we would consider to be a field. A field is a non-contact force, so it's something that can act at a distance. So magnets have their own field around the ends. We are going to show you, as you guys know, magnets can attract or repel. Okay, attract means that they go towards each other. Repel means that they go away from each other, so they repel the force away. So an example of two bar magnets that would attract would be when we have opposites, so a north and a south. And then another example of that would be a south with a north. Okay, so these would all attract towards one another. If we are going to repel, that is when they are the same. So if I had two bar magnets and I held both of the south ends together, they would repel. Or if I were to hold both of the north ends together, and I did not bring my magnets home with me, so I cannot show you, but you are more than welcome to look up YouTube videos of them, and I know we've played with magnets in class before, so you guys may remember this. So again, we have an attraction and a repulsion force. Now, one of the things that's really interesting is that when you have magnets, you can't really see the force lines on the magnets, but if you remember in class, I showed you guys little iron filings, and if you remember on a periodic table, iron would be abbreviated as Fe. So if you have little iron pieces like around a magnet, you can kind of see the lines. So you can, again, look up videos showing that, but I will draw you an example. So if I have a bar magnet and I have a south and a south pole, again, if those are the same charge, they're going to repel. So those force lines are going to be going away. If I have, let's say I switch the one on the right and I have them attracting, so a north and a south magnet attracting, you will see that the lines actually connect a little bit better, and the lines look a little bit different. So that's kind of a rough sketch. Now, some side notes to consider is that when the field lines, which are these right here, when the field lines are close together, that means that it's a strong magnetic field. And again, I'm going to use some abbreviations like we do in class in our Jones notes. So when they're closer together. Now, that usually happens at the poles because the poles are much stronger than like the side of a magnet. So when you put two magnets together, okay, the ends are obviously going to be the strongest part. If you have them where the field lines are further apart, it's obviously very weaker. When we were in class, I don't know if you guys remember this, but there are three types of magnets that we've talked about. So these 3 types of magnets are interesting. So we have, so I'm going to cloud that. So 3 types of magnets, one of which is like maybe the more common one would be a ferromagnet. So F-E-R-R-O, magnet, and the Fe refers to that iron. Okay, that iron. So this would be what we would kind of consider like a normal iron magnet. That's probably what we would consider the most common, just because if you have magnets on your fridge, it's made of iron, or magnets on your lockers or things like that, it's made of iron. Then we have what we call a temporary magnet. Okay, a temporary magnet is things similar to like when we did the scissor example, so it can become magnetic. So I'm going to show you guys an example. And then the third one is what we would call an electromagnet, which I will be doing on the next lesson also. But the electromagnet is when you're using an electric current to make a magnet. So those are the 3 main types. So ferromagnet, temporary magnet, and electromagnet. So we are going to talk more about electromagnets in the next lesson, but I'm going to talk about ferro and temporary magnets now. So I'm going to flip the page here. This is going to be not the best drawing, but that's okay. So the first one is a temporary magnet. Okay, so a temporary magnet is where you can just basically make something that's like made of metal into a magnet. So you guys will hopefully remember this when we did the scissor example. So like the end of a scissor is pointy. When you first have them, these little domains, these arrows, are all kind of pointing in different directions. When you rub a magnet, like a bar magnet or a magnet off your fridge, if you rub a magnet down the side of the scissors in one direction, so if you rub them all like going this way, so that they all will line up, then what happens is your scissors then will all line up those arrows pointing in that direction, which will then make it magnetic. So then in class we were able to pick up paper clips. These are horrible, horrible drawings of paper clips, but it will then pick up the metal paper clips. So that is what that means. So when the domains line up, so domains again are those arrows, domains line up, that equals a temporary magnet. Now the longer you kind of stroke the scissors with the magnet, the stronger that will be. Another topic that we've kind of talked about is magnetic reversal. This seems to be a little bit more complicated, I would say, for kids to understand, but basically we have Earth, and there's essentially like an imaginary magnet on the inside, and we have a south and a North Pole. Now, what you will find is this up here is actually what we would call the geographic North Pole. Okay, and this is what we would call the geographic South Pole. And I did draw it at an angle because it is rotated on its axis. So what happens is there's this magnetic field around the Earth, and it has these little domain lines around it. And what happens is when we have a compass and it's pointing north, okay, this north magnet, the end of the compass is a north magnet. We know that the north pole of a magnet attracts to a south pole of a magnet. So what happens is when we're taking a hike or we're using a compass, which I know a lot of you guys do not use, but there are compass apps that you can download on your phone. But if you use a compass, the north needle acts as a north magnet and it attracts to the south pole. So when you are looking at your compass and it is pointing north, that's actually the magnetic south pole. So that is one of the more confusing topics, but after every so often in the history of the Earth, it has actually rotated, so this magnet actually reverses. So that's what we call that magnetic reversal, is talking about this part, but also talking more about how a lot of kids think of it as the north magnet and then the south, like it's reversed in our thinking. So that is what magnetic reversal is. Not a huge thing until we start talking about erosion and different evidences of continental drift and plate tectonics, but again, that does have to do with the magnetic field of Earth. Any comments, questions, or concerns can be left below. Hope this is helping you guys. Have a wonderful day.